So this is a basic V4 engine concept idea I had. Um, the reason why is because I ended up learning that a V4 can be inherently more balanced thanks to a person that posts on YouTube. I think they're Fort9 or something. I think they're in Canada of all places. So that's cool. But anyways, I was debating between like, well, here's a toroidal engine, that I have, right? And then it's like I can technically extend it to like a full foot length, for the you know uh, lever arm effectively for the 12 different arms that are on it, and then it counter rotates, and then it has this like clutch torque converter quotation marks, not really a torque converter. Anyways, it's hydraulic fluid that goes from the center up, comes back down a little bit, and then goes back out, and then it goes back up. So it goes in at a diagonal, and it goes back up at a diagonal, and it comes back down, and it goes in at a diagonal, and then it comes back. So it makes it like a double figure eight, but there's two of those that exist, right? Kind of like an hourglass that's, next to each other. It doesn't really matter. Point is, it then engages a clutch like a turbine, and then it engages like the axle, so crankshaft thing. It doesn't really mean much to most people, but what it means is that it's like, well, that's also being. So first, I have to state that it's like that's should already been talked about before. Please go listen to that YouTube video. I have a couple of them already at that point. Search toroidal engine Xenon if you can't find it by scrolling. This is a fairly recent video, so like it wouldn't take very long to probably find that yourself. Please like and subscribe. Hit those buttons. But anyways, it was like, well, V4, technology already exists. We already have V technology. We can just cut off, another four of the cylinders for casting. Make it a little thinner aluminum block here, and then maybe sleeve it, make it like a closed, top for the engine block, and strengthen it a little bit more and make it so that way it has the proper, offset for the angle with a hybrid crankshaft, where it's like either a big bang, like a double big bang, or like a screamer, or I think like a double big bang technically because of what it's doing. It like it then is kind of like a screamer in its own right, you know. Uh, then it was like, right, well, at that angle, in the casting technology that we have, we can just make a like curved, elongated head. One whole piece that just gets on, bolted on, but it in the center is a intake manifold that has like the built-in little port injections or whatever you need, kind of stuff. And then I was like, well, if I'm going to make a new head and new ports, I can have the ports come in at the top instead with that intake manifold, since it's curved anyways. And then it'd be a structurally supportive member of the engine block, which means I can kind of lessen and lighten the load and shrink it down a little bit, but increase stroke length, so I can get a little bit more torque out of that. And then I was like, well, I have these, I can use a singular pulley because it's going to be a supportive structural member, the manifold, intake manifold head combo, and I have to bolt it anyways. I was like, well, if I have these camshafts a little bit lower, underneath the exhaust and intake manifold, that's, properly separated, of course, because we still need to have coolant run there and be able to allow for lubrication and coolant, for the camshafts along the side. So if I put them along the sides with a singular, connection for the serpentine belt to run all four, and I have dual overhead cams, except they're technically underhead cams. You know what I mean? But the reason why I was thinking about it is because if I use rocker arms, and then I happen to use like my diagonal poppet valve that's angled, so it's like, think about it being angled downwards, and then diagonally. So it's like, take a standard diagonal, all right, and then you, like on the z-axis, then from perfectly. How the hell do I describe this? Anyways, take a straw. So to you, it's flat, right? And then it's diagonal, and then angle one of the end pieces where the holes are towards you where you can see it, but make sure that it's still diagonally angled downwards. All right, and then when you press in on the camshaft with a rocker arm, it'll still on one side still be able to, the other side where like the exhaust is, be able to push in that poppet valve because it's going up and then down, so like another angle from the pivot point where it's at. Alright, now the reason why is because since it's coming in at a top angle where the intake is, and then going down at a diagonal with the poppet valve, it creates a vorticing like effect for better volumetric efficiency, and I can have a larger intake port as a result of this, with a better firing angle for my injectors, which are like direct injectors almost at that point. So that way, as gas and air come back in through the poppet valves, it then is able to try and vortex along the cylinder walls, take some of that heat away. During the phase change, it helps cool the cylinder walls. I can maybe even get that scavenge effect for the two-stroke, that I was trying to think about, but it was really about two-stroke. It was about the fact that it's like, well, it's now inherently balanced and it has more torque, and it can go pretty high RPM, and it's pretty easy to manufacture. All of the pieces now, cooling is sustained, right, and exhaust is up and out of the way, and then I can have it dumped down with equaling tube headers that are easy to just cast again, and then do like a double cast. So it's like a cast and then another cast, and then like I'm able to then suck out air, like a thin cast and then a thin cast, and I'm able to suck out air, and that way it'll act like a vacuum insulation. That'll be nice, pretty fast. I felt like that would make it easier, but the point is that it was supposed to be for like a turbo system, kind of like Formula One does with Mercedes-Benz, where they have a longer axle, to the front of the vehicle, where it intakes air and it keeps away the heat from the exhaust. So it's like, well, that's a good way to go about it. Then I can have that, then go through an air to air or something, and have more efficiency as a result, right? And it's inherently balanced, which is good. I'd prefer inherently balanced. That's angling and crankshaft timing, stuff like that. Right, so it's inherently harmonically and vertically, all that. Since inline fours have harmonic imbalances and are not able to be balanced very well, well, now this can get rid of that, which I felt was a good idea, and then I can increase volumetric efficiency. And since it's really only two pieces that I'm having to cast for the engine block and head now, even though it's a little bigger, it's inherently less complicated, with some rocker arms and all that, and it'd be a fast, cheap, easily sold, able to fit into most vehicles' engine bays kinds of an engine. But of course, not everybody likes the things, and I can always make them just a longer stroke to shorter bore, which we've been kind of getting away from. We've been doing overbore to shorter stroke, in engines for higher RPM. But it's, I think higher RPM is more about, balancing from the crankshaft, and crankshaft to camshaft, you know, like pulley kind of systems, since they're they're sort of parasitic, and by sort of I mean they're just straight up parasitic, but like you know there's not much you can really do about that sometimes, right? And there's still always an option of using hydraulic fluid, like with a 1-to-1 with a plunger system, where I don't need to spend nearly as much mass to be able to move it properly. And instead, now on the inside and on the outside, you can just do the work through that kind of a method. But it's that one's now a little bit, I guess, more complicated for some people. But I don't know. I mean, it's less weight and less mass, and it could still be 1-to-1 without needing to pre-pressurize the system, right? But then it's like people know about camshafts more, so I think you can probably still get away with a camshaft and still have like dual overhead cams, even if they're not overhead. So it'd be like dual underhead cams that still produce the necessary timing with better volumetric efficiency, and are able to run forced induction like most kind of 4-cylinder engines need. But because it's a longer stroke now, and then I was like, well, how come they don't run lean and then just burn more fuel after the combustion of top dead center has occurred? Like, you know what I mean? There's something that says that wouldn't work. As long as you can pulse it like a compression ignition, except it's burning, in a leaned out state, and so you can still force in more fuel after that and be able to get like a water methanol injection, right? To improve pressures, and since it's an elongated, meaning longer stroke to bore length, that'll work out, for overall energy capture and longevity, considering it's now more surface area contact for cooling. And since it can be better balanced, it should still be able to go to these higher RPMs, which is what you really need for horsepower versus torque. As now I have torque thanks to having like forced induction that's lean, but then like matching air fuel pressures, but because our air fuel ratio is not air fuel pressures, but air fuel ratios, but then I have a longer cylinder, which is able to be cooled, right, more efficiently. It should work out better, right? Anyways, it should be less complicated since we've had rocker arms for a long time. And then I was like, well, and the exhaust is easier because it's just like unbolted kind of near the top at an angle, and then it's just the intake is like the whole heads, so I felt like that was easy enough. I suppose if you wanted to put it in multiple pieces, that's your high performance or whatever that is crowd, right, for aftermarket, because it's like, well, it's just lighter, or maybe it's not. I don't know. It's more complicated for sure, but like this is now just a one-piece structural supportive member, which I feel like could be helpful, especially with the axle being able to be or the rod, that's connected to the turbine, can be more efficiently used with multiple points, either 1 or 2 or 3 or however many you need with the bearings to support it, like Mercedes-Benz does, because we already know that a single camshaft can exist with push rod, like in GM's style of V8s and V10s and so on. So it's like that's where the axle for the turbo setup is, which now has a easier time of becoming like a super turbo, because I don't like to dump more fuel after the exhaust has occurred, just because for me that tends to maybe burn ports or bearings, whatever it is. It's also more fuel waste possibly, but it spins it up faster But it's like there's nothing saying that a Venator doesn't work with like a spring and clutch system. So it's like it's a spring keeps it open, but then the spring gets overcome once it starts going. So it's like starts at a larger, then it goes to a smaller gear, and then it slowly opens up to a larger as it goes to higher RPM, and then the turbo takes over. Uh, with a clutch being popped off, by a solenoid, and mechanically, if the solenoid were to ever fail, that kind of thing, which is weights, and eventually weights have to be changed, but then it was like, well, weights are any kind of thing, so it's like, well, hydraulic fluid will work, and that'll run the serpentine outside of the camshaft, right? Unless you can kind of manage that to spin and match properly, and then it's just like, well, I can dump the rest of it directly into the camshaft with like a torque converter coupler setup, so that way it'll still spin up the serpentine and take over that, like the MGUK, because alternator has to be there. But then it's like, well, after a certain point, it's just like I can just dump the rest of it right into like the crankshaft, right, as a physical. But it's like, that's why it's like a clutch thing, for the Venator, supercharger part, because it's then able to then re-engage the clutch to spin it at various RPMs, starting off large and then going to a smaller and then eventually going to a large again for the serpentine connected to the crankshaft, which makes it a little easier. It's a tighter little fitting package that will produce a lot of horsepower and torque, I felt, at a lower cost of manufacture and a easier time of maintenance, because then it's just an intake manifold and heads, so like, which are all one piece, right? Because I'm pretty sure we've used to cast intake manifolds as one piece, but now we're better at it. It doesn't have to weigh like a massive amount. And I was like, angled valves have been around for a long time, but they're also like primo, like they're only ever on sports cars. You ever notice that? Like, you always want angle valves, like on any car that you can, like, I mean engine, that is, not car, but any engine that you can get, you always want to put angled valve heads that have big, huge valves that are like really good at being able to bring in the air at a very high efficiency that has low drag and low resistance to doing it. Well, poppet valves have always annoyed me because it's like they have to go down and then they have to go over and then back down again. And it's like, that's so fucking stupidly annoying to me. Why doesn't it just go like down and then just swirls down? It produces like a lower pressure zone in the center, and because it's angled now at the cylinder wall, right, and it's like it can come in from the rear over like automatically, so then it's really super easy for it from the top, and then in basically just start it immediately curving it anyways. Makes it more efficient and less restrictive, which, since it's always an air pump anyways, that tends to turn it into something a little bit more powerful for less inherent wasted time and energy, making the power sort of stuff. The reason why I was thinking about it is because it's like, well, everybody kind of dislikes these inline fours for trucks and sports cars, right? So it was like, well, an inline four can do it, but what would do it even better? A V4. There's a reason why they're used on motorcycles. It's for the exact same reason. It's like they're inherently balanced. They go to higher RPM. They can easily produce way more power, especially if you give them forced induction and make them balanced alongside of a longer stroke and a more efficient intake and exhaust. So might as well just do that. But I guess I should get off of it right now, because it's like, I don't think they'll ever do it, but maybe they will. You know, like that would be a really good idea because it's pretty easy to just easily kind of put it together and design it. You know, just they already have V8s, and so it's just finding the right angle and then doing that. But here's the little rub that I have. Okay, so this one's not really like the same as maybe other people, but you know how flat V8s existed back in the day. Okay, um, well, if I make the exhaust from the top go down into the bottom part of where the piston is, where the connecting rod and bottom part of the piston skirt happens to exist, and I'm just gonna push exhaust into there, but I have a just let's call it like almost like a girdle, but it's actually a couple of sliding parts, so that way as the connecting rods slide in and out, but also happen to be sealed and have the oil still go down, okay, into the little sliding parts, but then it has like a structurally thick enough and sealed part to the bottom here of the engine block where the crankcase is, which can be done, okay. Then it's like, well, on its upward stroke, it's able to take that exhaust and then reroute it to helping, gain a little bit more torque. Now, it's not going to combust anything, and it's going to lose energy. Of course, it'll eventually heat, so it can get some of that energy back as it comes in, and you can always water inject it, where in the bottom of that cylinder, or oil, or, it depends on what you want to do. Personally, I don't do any of that. I just have like a sliding valve that rotates, so it's like as it goes up, it rotates, and then it'll just open the side of the cylinder, and then it'll push in or allow in, really, or suck in. Well, it's pushing it out for the exhaust, and then it's pushing it down into where the bottom part of the cylinder is. Uh, it's just got some compression rings and oil rings where the holes are, even though it slides in between two of these pieces, and that allows for, as it pressurizes as it goes up, um, for oil to be squeezed out and then down into where the sump is. It'll still go down the cylinder. It's still going to have squirters that are there during the rotation of the valves, right? So it'll still squirt in oil to help with the whole process, not just on the connecting rod, but also the skirts if you want it to. But then as it rotates back to being open, instead of going for an intake, it then goes to an exhaust, which then goes into the turbo. So instead of having this other, well, I'll still have the pulley and axle and all that for the turbine to dump its energy into the crankshaft. I feel like this is a better, faster, more direct method. Instead of having to spend that amount of time to get that energy, this is more directly putting that energy in. Depending on how well it holds up, it'd have to be research and developed a little bit more. I think they already have a few of these designs out there, because it's like, it doesn't seem like it would be that hard. Like, other people would have had to have tried at least a little, right? But then I never know, that kind of thing. But it's like, well, the bottom now gets direct torque action, and as long as the seals are, properly maintained and gapped, like in a crankcase vent and header vent and all that, still has to. I mean, it's a forced induction anyway, so might as well. With the oil catch can. So there's that. Then it's like, well, yeah, no, that I suppose that'll work, right? Then it just drains it off into like a dry sump instead at the front, and then I just have to cool the axle, which already is gonna have oil. My dog is biting my arm as I'm talking to my phone, so I guess he wants attention. But there's that. kind of an idea, or it's like, well, it's possible. So it's like I have two pieces, two piece construction with the bottom part, and then it allows for with the you know pulley, the serpentine belt, and since the crankshaft is already right there, I can just add in the right kind of rod right there to help spin it up. The little rotating valves here that allow for the exhaust to then get routed in and then routed right next to it on out like a flathead V8. Okay. It's lubricated because, of course, the rods can't be perfectly straight up and down. But what that means is that since it has a sliding piece that allows for sealing to occur in that two-piece construction, that means it'll still run and operate smoothly, and that sliding is now like a pump alongside of the air pressure differences. And simple crankcase vent and the correct little opening little holes allow for oil squirting and cooling, and then like sucking it out with a pump in between those pieces, the dry sump pump, and that's just hollow. I usually use hollow, like a camshaft for rotating, because it's an axle with gears anyways. So I'll just make the gear parts just instead of indents, they're just cut-ins to the hollow axle that'll have like a couple of little Archimedes screws on the inside, because since we can rifle rods to shoot guns, bullets out of barrels, then I was like, well, there's nothing saying I can't just rifle it differently and allow for it to now be like a hubless or just a hubbed kind of turbine. Anyways, we have turbines with shrouds on them, so I was like, well, this will work. This is fine. It's still a pump. It'll go on the outside or the inside, whichever way you want to do it. And it allows for the oil to come back or be drained, or after getting pushed in from the top or the bottom, however you want to really kind of oil the whole thing. But that means I also have less oil in the whole system to act as parasitic loss, but now it goes to all the right places. I don't need as many valves anymore, like in the middle, like my other opposed piston designs often do for its new middle dead center action, which is usually not the middle dead center between the two outermost points of the cylinder. It's actually between middle dead center and outermost, because middle dead center is a combustion zone, and then the outermost points are combustion zones because of a basic tech like this. But instead of needing a sliding part, I just need like a capped part. I ended up thinking about other things. So it's like, well, here's how to make a basic rocket injector utilizing my toroidal engine. Okay, so it's like I suck in air from the top, alright, so in the middle. So instead of using like a compressor or any of that, I use the toroidal, like little, there's the intake manifold hollow part, and then it, counter rotates. Well, since it counter rotates, because that's just a basic series of bearings, and so as one side counter rotates, it then has bearings, which then make it so that way a clutch spins the opposite direction, going the same direction as the connecting rod and housing that's around it, into the spinning toroidal part, which has hollow connecting rods that go off into the toroidal donut shape at the ends and the outside, and then the exhaust just goes outwards on two sides, bifurcating into two separate. It doesn't matter. Like really, it's really not that big of a deal. Point is, you can go listen to those videos, but instead of doing that, I suck in air from the middle, but then instead of going into the intake manifold, it just it does. It goes into the intake manifold, but it also doesn't. So it goes through the two counter-rotating parts, and it kind of in the intake manifold, but I don't need it to be hollow. I'm not looking for it to be hollow. Okay, so the only parts I want to be hollow are the toroidal areas, which is where I'll put fuel in. And so since fuel can then be pumped into the toroidal cavity, and then since the air is getting pumped in through the center little tiny intake manifold and then dumped out to like the connecting rod arms that then go around and up like with a parabolic spike curve, it then goes and gets squeezed to the outside, which will have some fan blades to the toroidal, which are counter rotating. So all of that's decently efficient with a little shroud around it. It pressurizes the fuel and it pressurizes the air, which then goes into a basic chamber, which will then, which is a ring, with a cone in it. So it's like think of like a double hourglass, or well, an hourglass, but it's like a double teardrop, like with the bulbous ends on the end. So you think about it, it's like that's all hourglasses, but it also has an aerospike. So it's like it's an hourglass outer with an aerospike hourglass in the center. Now, the reason why I'm doing this is because as I fill up that chamber, I don't have to use compression ignition. I can just use a spark gap area as it goes through like little, like because the toroidals are spinning and they have to balance on something, right? So if I put like little bearing, sliding kind of parts there, then it'll open up holes briefly, and then once gas and air has both been pushed into this area for the double ring, it then forces it, thanks to that pressure inside of the system, to then remain open, no longer being able to slide into the holes that they're there, keeping them pressed open, and then continuing a burn as it spins. So they'll use that accelerated air and then that pressure opening area in the middle. All right. That's a good way. So it's like it goes into a smaller, more compressed environment that then accelerates towards the middle, but because there's an opening that's larger at the center, to its view, it kind of looks like it stayed the same pressure, except it just accelerated, and then it'll get recompressed towards like the ring area, but then it's going to expand into the cylinder, right, through another ring opening, except this one has a little bit more of like a star shape or an asterisk, so that way it helps, my dog is biting the hell out of my arm. If you don't know and you can't hear it, he is just going for blood, it feels like. He's being a little too aggressive with it. I'm gonna go stand over there. Anyways, what it means is that it has a larger opening, but instead of trying to capture it, or instead of trying to accelerate it, I'm just trying to have it diffuse throughout the entirety of the cylinder's, volume. So I don't have to produce accelerative thrusting force onto the head, and it's getting cooled anyways around that because, lubrication and coolant still has to go through to run this, which can help accelerate those parts. I was going to use the camshaft as well, but also have like that there too, right, as an extra pump power, kind of cooler as well, so that way it doesn't want to die, as I have those stator star areas, so they'll connect in certain places. It diffuses it a little better. It's a little bit more efficient too, which is a good thing, but then it means it's a one-stroke injector that's a part of the head that can be easily replaced. Then it's like it just needs exhaust. I don't really need anything except for intake manifold to allow it to go into this, and then a fuel rail that connects to it. So mixing is a different valve and different pressures that you would set and then tell it to inject. I go with inject. I'm gonna go with inject. Yeah, inject into the cylinder for that duration of time, and then exhaust at whatever point that you want. You don't technically ever really have to fully stop sending, injection, uh, because by the time it gets all the way to the bottom of the center, if you don't use like a lot of air and fuel, but you're constantly injecting, combusted gases into it, but then you open up the exhaust, then it's just going to go out, and you can keep injecting because it'll go off into a turbine now. So like you'll capture a degree of that energy, which is why it's like, well, how hard is it to make a turbine that's a little bit longer and more efficient? That kind of thing, right? It captures a little bit more of it a little bit more efficiently. That's another reason why I was like, well, if I have two off to the sides that go from, but it's like, oh, well, that'll just go directly into my upward trajectory at the bottom of my cylinder, and then the rest of it will get captured into a slightly longer, sort of like a steam engine or a steam turbine, sorry, where it goes in the center, but instead of the center, it goes through a hollow turbine center that just helps spin it a little bit for higher pressure, and then it goes from the center out and then outwards, right? But I kind of don't want it to go out. I want it to go out only one side, so it goes from both sides towards the center, but not really. A good way to put it is like, I know, it's like, that sounds really complicated. A good way to put it is it's a tube that has, turbine blades in the center of the tube, and then like on the outside too, it has little turbine blades, and then there's a housing that has stators that are there, but then there are holes that are properly positioned in the center that then have it come from that center outwards, and then from those two parts on the outside, combine them like an equal length tube header into just a singular. So it's like this outside and that outside then have to take a certain degree of distance towards this turbine fan blade system that's longer. So it's like a good way to put the turbine fan blade system is it's just bigger, wider blades, for the lower pressure. But instead of like a Peltier where it goes backwards, or like this one's kind of like a Jules Thompson where it goes from small, high pressure to like a large kind of medium pressure sort of thing. But this would be the large, very low pressure at the ends, but it'd be outside of that spinning, initial tube with the housing. So it'd be outside of that housing that would then connect like an axle to like a differential. So it's like that would be on one side or another, or in the middle. That would then connect with those holes that would then go to this one, which would be the outside of the fan blade housing hub. Which turbine housing, not fan blade, sorry. But that would then go to like a gear, and then you can then add it to the main axle that goes to the compressor kind of system. You know what I mean? So I capture more in a smaller area that's more efficiently captured, right? But I have to start from the smaller, and then it gets wider at the medium, or in the middle, I mean, and then that's a smaller area that then goes to a wider area, and then that goes off into a equal length, and then to a bigger, wider, fan. Now it's more compact, sure, but it's you have to remember it's still going to be a wider, bigger, heavier turbine capture system. It has more loss because it had multiple 2 gears and a bearing, system in between the housing and all that, because I have to have stators there. So it's like those are where kind of the bearings are, But it's like, well, those are bearings, sure, but the housing is its own kind of bearing sort of thing. You have to have fluid to a degree to help the bearings, you know what I mean? But like turbines already have bearings. like they have to have them somewhere, right? So like they have to float somewhere connected on something, and I already have the exhaust manifold, so it's like, well, let's just put them outside. Let's just put that outside, and then here's a gear to connect the, so like I think it'll work. It doesn't seem like it wouldn't work. So it'll get back some more of that torque, and then it's a lot more compact, even if it is heavier. But it's like you're not getting more efficiency without having more, weight be added. You know what I mean? Like you could never do that. So but at the same time, it's like it's more captured energy because I'm using the bottom part of the stroke length, and then I'm also getting a rear mounted turbo that's, I guess, basically just going to be a part of the engine block, is just kind of bolted to spots where it's supposed to be bolted to, and that would be fairly easy cast at that point because it would have cooled pretty decently, so I don't need like really high temperature like titanium blades. I could probably get away with like decent steel with some coated ceramic to help it, and cast that and powder coat it, I suppose, and make that, get the right tolerances, right? And then it's like off to the catalytic converter. Have fun. Since it's coming off one side anyways. The back pressure is sort of managed at that point because the back pressure is really just creating torque to your crankshaft, from the bottom part and then on into the turbine. Anyways, I feel like the turbine kind of has to be like that, just because it's like it's going to be a lot less energy, right, that you could capture, so you kind of need it to be a lot more efficient at capturing it in a smaller area as a result, kind of a thing. And since it has to be in the rear anyways, and it's near the bottom, it makes sense to have it like a little bit above where the flywheel and clutch area is, right? So like that would probably work just fine. And then it means that depending on how you want to mount it, that allows for left or right, singular exhaust tube to your catalytic converter, which should still be hot enough to make sure your catalytic converter still works, right? And it doesn't matter as much because you have a super turbo, meaning a supercharger turbo combo that has the venturator, and then also, which means like a infinite kind of gearbox system with a clutch and spring setup to help with like improved efficiency at startup, and then higher pressures to help with the rocket injectors, like I like to call it, even though I guess it's for some people not, even though it's a pump that goes into a combustion chamber that then blasts that kind of into a sort of a bell end, I guess, but it's not, but the bell end's really just a capture point because it's a piston and a cylinder. So it's like, I think I could get away with calling it, because it's a pump, but it's also a compressor, but it's not burning anything. It's using actual, and then that creates quote-unquote thrust, but it's not really. I'm trying to make thrust. I'm just trying to make very efficient combustion in a small space, and I then can have a larger area off to the side, and then I only need exhaust. So it's a one-stroke injection system. It's like, well, if I want super high performance, I'll just never stop injecting. I'll just use like upward, exhaust with the exhaust open for that entire time, and then I'll just start it again. But I can run leaner mixtures as a result of that, but then I'm also like, well, yeah, I don't really maybe need to do that, you know what I mean? I can probably just get away with like a regular sort of style of setup where I just inject and then I let it exhaust fully and then I inject or and let it exhaust somewhat and then keep a degree of air spring throughout the entire system as a hot combustible gas air spring that'll still go into the chamber, and now I don't need as much of a spark, because it'll just compression ignite. Once it goes from top dead center down, you get the right pressure, and then you can start the whole process over again. But anyways, it's just a concept idea, because it's like, well, now a V4 makes total sense. Like, you wouldn't want anything other than a V4, because it's basically like a two-piece construction design. Well, technically kind of like four. Well, when you really break that down, it'd be, well, you have exhaust manifolds in the turbine, so it's like, I don't know. I would think it would work. I'm just, spitballing here, but I'm pretty fucking sure it would work, Anyways, it'd be a fairly efficient system for capture of energy, even if, like, I don't get to use my propane. Because I was thinking about propane, right? I was looking at this Driving for Answers guy, and he was like, oh, yeah, no, Stirling engines. And I put out a Stirling engine video. But then in the comment section on my Gray Life YouTube account, I commented on this guy's post about how he used a Stirling engine with propane to heat up oil to run like a 6-cylinder rotary. And I was like, well, if it's sealed enough, and I have like automatic, if it detects too much drop in pressure in the engine, then it's gonna immediately shut off, right? For the engine coolant for the propane going into the engine, because it's like, well, I'll use the propane, the liquid propane, to cool the engine, and that'll warm up the propane and give me pressurized propane in my fuel rail that I can then use with my injectors. And as long as I seal it properly, and then even seal around like the heads a little bit, and then have the automatic shut off if it detects too much of a drop in pressure too quickly, like during an accident. But see, here's the thing with an accident, just FYI, engines burst into flames usually, but like in this instant, because it doesn't have enough oxygen readily available very quickly, because it would be a lot of sudden release of propane, it would saturate the area, and then it would have to go, and it would really dramatically cool significantly the air if it were to leak very quickly like that, and there's not enough real air to combust. So, but I was like, all right, I'll seal it, and I'll have like safety measures and all that. And then now I don't need like a radiator, so I have less weight on that, and then a basic kind of cryo cooler that uses the Stirling engine and like the reverse of a Stirling engine effect with a Joule-Thomson cycle, and the phase changing of like the air, like, so it's like a water to air intercooler, but I'm putting propane through it, but it's a triple. So it's like the phase change on one side, if I'm trying to suck it back up into the propane tank from the engine, then allows the propane to be cooled. It helps cool the propane, and then I can cool that and then compress it and then put it back into the propane tank. You know what I mean? And remove more of the propane that's in the engine, right? Instead of having that slowly warm up, then I can use that to help gather up some of that gas back. I just need the batteries and so on. And then I was like, well, the compressor can still act as like a propane compressor, at least a little bit. But then I was like, no, that's a lot of actual electricity. Yeah, there's a better way, I think, of doing that. Especially when it's like, well, I have an alternator, and so for the amount of energy I try and use to store the propane, I'll get a certain amount of it back using the propane to cool my engine and power my engine. So it's like I run super lean with a pretty high boost, because propane tends to like that anyways. And it's like, well, I can use any amount of natural gas, or any real gas, like methane, butane, propane, that kind of thing. It's like, well, that's a bunch of like fecal matter and you know other stuff that you could get a lot more cheaply, more easily, that burns more cleanly in general. You know, and then I have like I of course have to get it off of the headers. You know, so that's like I also have that header coolant area. You know, help the fuel rail. So it's like it goes and dumps into the fuel rail as well. The turbines, since I was thinking about using a 6-cylinder, I'd get like a much longer, you know, turbine, since it's already going to be a long engine to begin with. And so it's like, well, if I do that correctly, then it shouldn't weigh too much more. And then same thing with the compressor. So it's like, oh well, you know, given a certain amount of energy storage, because I was thinking of doing the same thing again with the serpentine belt sort of thing. And then like, oh yeah, I didn't talk about it, but it was like, well, if I make that sliding bit and then like the bottom part for the engine block and then dry sump and all that, then it's like, well, I get all of that from that, and then I have a single injector that little, so I have a direct injector and a port injector. So I'll port inject and then I'll direct inject from another fuel, the same fuel rail actually, truthfully. But anyways, after I run super lean, and then I'll inject, you know, fuel as it goes from top dead center down to bottom dead center. But you know, those are always like cylinder pressures. It depends on what you can do. Like top dead cylinder pressure, you know, top dead center or near can be you know, high, but it's not like as high as you think, because as it expands, once it gets hot, of course it drops. But then cylinder pressures over a given surface area, you know, like in a cylinder, can be handled a lot more easily. The only problem is that compression rings have to be correct, you know, the right gap, right? Anyways, but it's like, well, that's a whole hell of a lot to kind of like do. But then, you know, straight sixes is what I'm talking about, are easy enough, right? Those can be found. And then producing like a bottom to it is not impossible. You know what I mean? And then a longer turbine, another version of it's not impossible to do. You know? So it was like, and same thing with a torque converter slash, you know, torque, you know, a hydraulic fluid coupler to like, same thing with a venerator that uses hydraulic fluid, since, you know, that would help anyways. And then a spring and, you know, all that stuff. So it's like all of that's doable. And then it's really the compressor part, because it's like, well, a Jules Thompson, like a multi-phase Jules Thompson, it was possible to, especially with like pre-cooling, and then, you know, with the phase change, but that's why it's a 3-part. So it's like that only seems like 2. It's like you're right, but it's like if you have a third one that allows for it to move back in with the flow of the gas, that helps with repressurization of that gas, especially since the engine's still going to be warm, and so that'll still try and get you know, reduction of the compression overhead that I'll have, as I really just need to cool it more to help suck it into the compressor to then, you know, go back into the propane tank, the gas tank. So like I was like, well, that'll work. I just need enough battery to do it. And so like for the battery, another compressor, you know, the right setup for this, you know, I think I'd be around the same amount of weight as a comparable, like, you know, straight 6 with forced induction and, you know, unnecessarily much larger radiator, and the air-to-air cooling or water-to-air cooling that they're using, the wiring, you know, like all of this stuff that you have to add on, like starts taking up a lot of weight to make that kind of power, and I wouldn't need that weight anymore. And so it's like I'm sacrificing that weight, and I'd be pretty close. I think it'd be just under if I do it right. You know, so there's that. And I was like, well, same thing with like now a V4. It's like, well, fuck a radiator, you know what I mean? I have a turbine here. I can do all of that. It's less weight now. It's inherently balanced. Now I have a rocket injector, so it's like, well, that'll work. They use that. They use propane. They use methane. They use that for rocket injection, yeah, or rocket thrust. But we're not doing thrust. We're really just trying to make it like get pressures and continually, and that's why the chamber allows for higher pressures, and then the nozzle size allows for continuous maintaining of those pressures inside the volume of the cylinder. You know, that's all that would be. That's why it's like got the whole teardrop or star shape with the stators that aren't going to capture thrust. It's just trying to diffuse it. But then it's like a Tesla valve, so like it doesn't want to go in. It wants to stay in the cylinder. That it's right compression, right gasket material like multi-layer steel with some aluminum and high temperature silicon. At the right torque levels for the bolts or studs. For the nuts at that point, I guess. It should work. I don't think it wouldn't work. It's probably just like something that most people just haven't thought about, because like V4s are mostly motorcycle engines, and then so they probably wouldn't use them much, in actual like high performance, and that's why the Porsche for their concept, or not concept, whatever their car is, the high performance sports car that they have, was like, well, that sounds really good. You know what I mean? Like, that's a really good sounding engine. I can do something like that. You know what I mean? Like, I can do something like that. There's nothing saying I can't do something like that. It would sound way different. You know what I mean? I was also thinking about it for Formula One. I was like, oh, yeah, no, Formula One would, instead of fucking inline fours, give me a damn V4. Why not a V4? What is this, right? Like, I can't balance this nearly as easily as a V4, right? So it's kind of another version of that. It's like, well, this would work. It's way better balanced engine, Anyways, your dog's finally no longer going after me. I think I'm kind of done with talking about this. Who knows? Maybe someone will want to work with me to make the engine, put it out there. I love that. Seriously, I mean that. I'd love to work with a lot of people to get my concepts out there and built, and maybe make some good money. You know what I mean? Even if I'm a little eccentric and a little out there sometimes. Especially since it's like everything's going all to like electric motors, and I'm like, yeah, no, I know, but it's like waste heat generation. Converted into actual like work energy, it needs to be figured out better, because like that's the primary main energy that's everywhere, and if we could figure that out better, then we'd be much further along than trying to convert a given waste heat or heat energy into electricity and then using electricity. Especially by not needing to burn chemicals, or like exothermically react compounds is what I should say. But a better way to phrase that for me is like, if I were to react compounds more correctly in a more controlled manner, I can get more out of them. Especially if I do it in an acoustic pump multi-tube setup, where during that exchange I can then gain more of that energy as like actual work energy, as it will help vibrate and like actually push things. Even if I have an opposite reaction, that opposite reaction can still be used to help drive the whole thing along as like a pump that fires it into making the reaction occur, thus continuing it for longer, so it's not as wasted. You know what I mean? Right? But then it was like, well, the same thing for like fucking light and heat from the sun and earth and shit. So you just drill down far enough and just stick a couple of whatever the hell that is, and it'll do the same thing, piezoelectric style, and like vibration shit and some cooling. It'll work just fine. You know what I mean? So, anyways, have a good one. Uh, Remember to like and subscribe, please. You know, all that. Bye.